Okay, let's start. First, a bit about me. I'm Niels van Hoorn at NVH on Twitter. I'm an iOS developer at NRC. I'm one of the organizers of CocoaHeads, and I'm the creator of Forens, a notification app for a train you take every day. And I'm going to talk about protocol-oriented data sources, and of course, in Swift. Does anyone remember Krusty? Well, for everyone who doesn't, he was one of the main characters of this talk at WWDC 2015, Protocol-Oriented Programming in Swift. It kind of inspired this talk, or this session. And if you haven't seen it, this is the best talk at WWDC ever. And if you're not, who's developed any Swift? Okay. Who created a custom protocol? Who created a protocol extension? Who created a type alias on a protocol extension? Who created, well, I'll show you. So what we're going to do is we're going to try playgrounds. And playgrounds are kind of buggy, so we're going to be forgiving to Xcode. Okay, let's start. But if you don't understand anything or have any questions, just ask them. If you think there's a bug, just shout out, and then we'll work it out. And now I want to know from any of you guys who I mean with this. Exactly, James Bond. So we're going to start with him. Because that's the data we're going to use. I've created some custom data, and I have some James Bond movie names, and here we have all the James Bond movies. I also have some actor names. Those are the actors, and I also have some movie years, and that's the years the Bond movies came out. First, I'm going to show you a little bit of boilerplate I had to create because of Objective-C and Swift interoperability. I have my own custom table view data source protocol because otherwise I can't use all the awesome features in Swift. This basically maps exactly to UI table view data source protocol, but that's an Objective-C protocol. Instead of optional functions in protocols like you have in Objective-C, you can create an extension with a default implementation on a protocol, and it's kind of the same thing. So basically I have table view number of rows in section, self for row at index path, the basic stuff you know from a table view. And for number of rows in section, if we don't define anything, we basically always have one section. If we don't define a title or a footer, we just return nil because because it's an optional here. Then I have some boilerplate code to show a table view in a playground. You don't really have to care about this. The only thing you need to know is that we have a variable or a constant default cell identifier, what we're going to use for our cell identifier. And I had to create a proxy class to proxy the UI table view data source to my own table view data source. And I just initialized this with my own custom table view data source, and then reroute every method to the UI or from the UI to table view data protocol to my own custom table view. Okay, let's get started. I'm gonna create a struct data source. And this is gonna go away. This needs to be a data source. And now we're trying to pass in the data source here, and it says, well, we don't, it's too small, but we don't conform to table view data source, and we expect that here. So let's conform to table view data source. And for that, we need to, here you go, we need to implement two functions. We need to implement, let's see, table view cell for row at index path. And we need to implement table view number of rows in section. Well, first we're going to just have a static data source that just returns 4 cells. And this is the boilerplate code you write every day. DQ, reusable cell with identifier. And here we have our default identifier I showed. And we have an index path. And now we have a cell. And we can configure that cell with, and we can set its text label with a specific text. And we do it with cell with of at row. Index path, index path dot row. And we return this cell. And now here we're gonna see our table view. Okay, this is great. Does anyone follow this so far? Yeah. Okay. Cool. So this isn't very flexible. I need to have all my code configured here, and I want to use my own data. So I'm gonna have a property data, and I'm gonna use the James Bond.movie names for it. Now I want to use this data, so I'm gonna say, okay, the number of rows we have is data.count, and the text we have is data at indexPath.row, and then we have all our movie names nicely in the table view. So this is our movie data source. And now we're also going to create an actor data source. And what do we need for an actor data source? Well, we need some data to work with, so JamesBond.actor names. And we need to implement basically these methods again. And then if we have the actor data source and we run it, oh, and we need to conform it to table view data source, otherwise it won't work. And then we have all our actors. Well, this is duplication of code, and we don't like that, so what are we going to do? We're going to make an extension on table view data source that contains these methods that are the same on both these. I'm going to make public extensions of everything. This is because I want to copy code away later, and otherwise it won't be public, and then, well, it won't give you an error, but it just crashes. So now we're extending table view data source with this stuff, and then we need to conform to table view data source, and I can copy this away, and hopefully it will give me an error message now, because who knows what's wrong? Yeah, exactly. I can't access this data just from any table view data source extension because it doesn't exist yet. So what are we going to do? We create a protocol, a public protocol. And we call it strings containing, yes. And it's going to have the data. The data is going to be an array of strings, and we're going to get the data. And now we need to conform this, these structs. We can conform them to string containing. And they already contain a data which is of type string, so that's easy. We don't have to do anything there. And we contain. This is a protocol, and if you create a variable on a protocol, you need to specify if the protocol should define, or if the objects or structs that conform to that protocol should only specify getters for that variable, or should also you can also say set here, and then you have to specify a setter for this thing. Now I think of it, we had var here, but this data is static as hell, so we can just make these lets. So now we need this data, we need it in this table view data source, and this is a really nice feature of Swift. You can specify on which protocols you're gonna, or which conformers of this protocol, you're going to have this extension. So we basically say string containing. And now what we say here is that we're going to make an extension on table view data source, but only if the conformer to this protocol also conforms to string containing. And in this way, I have two different protocols that specify different things, but I can define the table view data source methods with the data that comes from the string containing protocol, which is pretty nice. Okay, well, we have our actors, we have our movies, and now I want to use years. So I'm going to, wait. I'm first going to show you that this doesn't only work for the actor data source, but it also works for the movie data source. And now I want a year data source. And then we're going to run into some trouble. I make it a table view data source. I have the data here. That's data James Bond movie years. And now I want to use this great extension I created, but I can't conform this to string containing, because although I have a data property, this data property is of type int, and it isn't of type string that I specified in my protocol. So what we can do in Swift, we can create a type alias, and we can what we do there is basically tell the Swift compiler there is some type that if you implement this protocol you need to specify, but we don't know what it is yet. We only know that in the signatures of these functions and in these properties that I'm going to define on this class, this is going to be of the same type everywhere. So here I create the type alias, and then in the same way I create it, I can specify it. So for the string data sources that contain strings, I say, okay, this is a string, but these movie years is an array of integers, so I specify that this is an int. And now it can infer the item type for the protocol, so it knows, okay, if I conform to string containing, then it works. But now here, what gets returned here, I hope this error will, it basically expects a string here, and this returns something of item type, and I can't just cast that to a string or something. Well, I can just do this. And then it converts it to a string, and now we have the movie data source, but we also have a year data source, and that shows me every year. But this isn't really flexible, right? I have this extension on table view data source, but I have this configuration of the cell, which is always like a string representation of the data I have. But maybe I want to do more. I want to have a second label, or I want to do something extra with this data. No, I'm forgetting something. This is called string containing, but it doesn't contain strings anymore. It contains data. And we're gonna make a public extension on this public extension on data containing that makes stuff nicer. It just says number of items, which is an integer, and we're going to return data.count, and we're going to have a function that is item at index int, and it returns an optional item type. If you just would return data at, let's call this index, data index, you could actually crash your program by calling an index that doesn't work on this, or an index that isn't available in this array. So we're going to create a guard and say, well, my index should be smaller than the number of items I have, otherwise I return nil. Well, with this extension on data containing, these properties and functions are available on everything that implements data containing. So I just created data containing here. I should specify here that this is data containing as well. I can, instead of using this data property, which maybe I don't have the data directly, or maybe I have an optional data property, or I don't want to just have an array of data. Yes?
The magic has failed. You should return data index.
Yes, thank you very much. Yes, and it compiles again. Okay, we can here just use number of items. And here I can, instead of saying, well, let's say let current item is item, good morning, index path dot row. And I have a current item, but as you might remember, this item is optional because I specified here in my protocol that my item is optional. So only if I can find this item, I will set the text label on this. Well, this works, but isn't really flexible. What am I doing wrong? Oh yeah, here I need to specify current item. Again, this works for the movie data source, and the year data source is the same. But now we want a way to configure our cells. So we're going to make a protocol that is called cell providing. And this has a function that configures the cell UI table view cell with an configure for item. And what should I type here? What is exactly this item? Well, it is of item type, but I can't use item type here because I specified it in data containing. But what I can do, I can just say, okay, this protocol has an associated type with it as well, and it's also called item type. And then I say in table view UI table view, and we're gonna return the UI table view cell again. Is this correct? UI table view cell. Okay, so now I have my protocol cell providing. And I had this code here that had some, well, it did something sensible for a pretty generic case. So why not you make it the default if you don't, if you conform to cell providing, but you don't implement this method, by default, it's just going to convert to the object you pass, you have in your data source. It's going to go, oh, hello. Yeah, that was my playground crashing. And we're there. Let's make it a public extension. We are going to configure this cell by saying, okay, the text label.text is just a string representation of the item I pass in. And it actually, yeah, and we return this cell. Well, I defined a new protocol here, but I also gave it the default implementations. And that means that I can conform any type to this protocol. It doesn't matter at all. I can just say, here I can say cell providing, because the protocol defines, okay, you should implement this method. But then I go and say, okay, if something defines, or if something conforms to this protocol, this method is configured. So it's automatically set up with something default. So I can conform my data sources to cell providing. And then here we go again with the extension on table view data source. We not only say it needs to conform to data containing, but it also needs to conform to cell providing. Because of that, I can just, I don't have to specify anything here. I can just use the configure method that gets the cell, passes the current item, passes the table view, and I think this, yeah. And this works for my movie data source, for my actor data source, and so on. Okay, that's nice, but now I've created these data sources here, and well, they're yeah, sure. That's a good question. You don't have to return the cell. You could just make it pass by reference, because UI table view cell is a class, and we can just configure it and then say, okay, this is just a static thing. But I like to return these things, so these methods can be stateless. They can be, if you want to create your own table view cell from the table view with another identifier or something like that, you can just return another cell that you got in, but you get a cell, because that's most of the time what you want. If I have some time, I can talk a bit more about that. So where were we? Yeah, the data sources. These are basically just wrappers around array, right? The only thing this struct contains is just some array data, and the same holds for this, and the same holds for this. Can't I just generalize over that? Well, we can. What we basically can do is we can say, well, array should be extension. Array should be data containing. As you might remember, we need to specify the item type that we have. And array already has, if we go to the definition of array, it already is a generic type that has an associated type that's called element. So basically it says, if you have an array and it stores something, that thing is called element. So what we can say is, well, we are going to conform to data containing, but our item type should be of the same type as the elements that are in the array. And then we need to conform, or we need to specify what our data object will be. Well, it will be an array of item type. This needs to be public, because otherwise it will complain. And here we should return an array of item type. So how do we create an array of item type? Well, this is an array of elements, and I just said that an element is basically an item type, right? So I just could return self here. And hope it works, yeah. So now I've conformed array to data containing. I already said that it's basically free to conform anything to cell providing. And if something is data containing and cell providing, it can conform to table view data source. So here I basically don't have to do anything to get all this functionality that I created on these data sources before for free, but just on array. And to show you the power of this, let's just get the James Bond movie names, and they will be available in our table view. And the only thing this is an array of strings. So I basically can take any array of strings and just render them in any table view right now, which is pretty nice. And I can also do this with movie years and movie actors, or actor names, sorry. So, okay, well, let's get a bit deeper now. I'm going to move this away, as I said, to a separate file, just to keep some overview here, and it's going to need UIKit to not complain. I really like these, but I really like these, but I have to remove them, otherwise, well, at my testing, everything crashed. And we're just going to work with the movie data. Yeah, with the movie data source. Sure. Okay. Well, this is nice. I'm going to put this again here, movie data source. Well, I have the movie names here, but what if I wanted to know what year these movies were in? I have this list of years. What if I want to create that? Well, obviously I don't just have arrays of these things, but these things are in an object, and this object is called movie. If I say, okay, my item type is movie, then I should provide a list of movies. So I can say here movies. And because the cell providing protocol, as we remember, just converts any object that it gets, it converts it to a string and puts it in a label, it still works because I've created an extension on movie that says, I know how to convert this thing to a string, and we just return the title. If I wouldn't have this extension, then Swift would just imagine its own implementation of converting this object to a string, and it would look like this. But I really like that, so let's put it back. Let's remove these. Okay, so now what did I want to do? I want to set the year. I want to have it as a detail label. Well, I'm conforming to cell providing, which says, okay, I'm gonna configure. I know how to configure some cells, but I don't need to use this default implementation. I also can just say, okay, I want to configure my own cells. I don't care about your default implementation. And then I get here an item, which is of the type movie, because I specified here that my item type is movie. And I can configure my cell with it. So I say, okay, I want a text label, and the text of my text label should be the name of the movie. Is it name? No, it's the title of the movie, I think. We should return the cell, and then I can say the detail text label of the movie should be the year. Wait, it's the item dot title and the item dot year dot description. So here I had this protocol that's called cell providing, that has this configure method that basically converts anything you have in your data source to a string. But I've overwritten it in my own data source and said, well, it's fine that you have this configure method, but I'm going to take care of configuring my own cells right now. And the only thing I had to overwrite is this configure method, because all the other stuff still works. I don't have to you call this DQ reusable cell with identifier. That all stays the same. The only thing I care about is configuring my cells. Well, this is a nice list, but wouldn't it be nicer if we had some sections in it? So let's create a protocol that is called section type. And for now, this section type is just data containing. Because if you think of it, data containing was a list of data, an array of data, and we could ask like a number of items and the index of an item of data containing. And that basically is what a section of a table view is, because it also is just a list of items that are indexed by row. So for now, I'm gonna say, okay, my section type is just something that has a number of items, and I can get the item at a specific index. I need another protocol that is called section containing. And in this protocol, I'm going to use a type alias for section, because I don't know yet what type my section is going to be. But I'm going to do something new here. I'm going to say, yeah, you can specify your own section, you can have your own type, but it should be of the protocol section type. So I don't really care what the type you pass me on later if you conform to this protocol is, but it should be data containing. I should get the number of items that are in that section, and I should be able to get the object that is in that section. And what do we need more? We need to have the section, obviously. Sections. And sections is an array of this type that I just specified earlier, and I need to be able to get this method. Okay, this is cool. So let's take our actor and conform it to section type. Well, what do we need for a section type? We need data containing. So what was data containing again? Well, data containing specified that I have a property that is an array of item type, and it's called data. So let's just paste that in here and say, okay, my item type, what is in this section are actually movies. So my item type is movie, and I'm going to provide you with a list of movies. And what is that list? Well, I've actually, oh yeah, this should be public, whatever. Inside of an actor, there is conveniently an array of movies. So I can return movies here. So now I've, oh yeah, this needs, so now I've conformed my actor to section type. So I basically said, okay, if you want sections, every actor has its own section, and every section is data containing, and what the data is that it is containing is a movie. So now if we go back to our data source, we know that we have other methods on our data source. We have func table view, or no, it's called number of, what's it called? Number of rows? No, number of sections in table view, yes. So this basically says, okay, it has a number of sections in table view. I'm going to specify that my table view source should conform to my section containing protocol. And this way I can access the sections property I've defined in the protocol, and I can just say, okay, the number of sections I have in my table view are the number of sections I've specified in my section containing array, or in the array that is defined by the section containing. So how do we get the number return? Okay, so this is return. How do we get the number of items that are in a section? Well, we can just say, okay, sections, and we get the section, the section at the index that is asked of us, and we return the number of items that are in that section. And here we have an item at index, but we don't longer have this because it isn't no longer containing or conforming to data containing, but just section containing. So we should probably provide a method in our section containing protocol that gets you the item at a specific index path. So we're going to make a public extension on section containing, and we are gonna say that we're gonna return the item at a specific index path. And what's it we're gonna return here? We used to have this thing called item type, but well, the section containing protocol itself doesn't contain an item type. It just contains a section. But the section is of type section type, and section type is data containing, and data containing has an item type. So what I can do is basically say, okay, the type section that you had, that contained an item type. So I'm gonna return the item type that is specified by the type of the section. And now I need to implement this method again, so I'm gonna return sections does, and because this section is of section type and is data containing, and I previously implemented this item at index, I don't have to get the data of that item and get the index of it. I can just here call item at index, at least I hope, because it doesn't auto-complete me. Index path, oh wait, I need the index path dot section here, and then I say index path dot row, and it automatically returns the item here. Of course, you should also guard this, but we're just gonna forget that because, well, it's a demo. So now I know how to get the item of a specific section. So here I can say item at index path, and I can provide the index path and it returns. Oh yeah, this is something interesting. Where is my here? I said before, section containing has a section, and section is data containing, and data containing has an item type. So I have section item type, and then I have cell providing, which also defines an item type. And previously, I glanced over this because I knew we were going to come back here later. These item types are named the same. So we have two protocols called data containing and cell providing that both have a type alias item type. And you only need to specify it once because the Swift compiler knows, oh, you probably mean the same item type. So here, it was easy to have the item type that was defined by cell providing have the same one as the item type that was provided by data containing. But now, because we have a section type that has an item type and cell providing still has an item type, the Swift compiler doesn't know how to match up these two items. But the only place I need these two items to match up is the place where I want to use methods from both protocols. And that is in my extension on TableView data source. Because here I say, okay, I have a section containing protocol, and I have a cell providing protocol, and I'm going to use methods and properties from both protocols. So here in the definition of the extension, I'm not only going to say, okay, this extension of this protocol is only valid for the if the implementation of this protocol also conforms to section containing and cell providing, but the section type item type that is defined in item containing should be the same type as item type as defined by cell providing. So here I'm restricting my extension even more. I'm saying if these two things have the same type on this place, then I want this extension. Is this followable? Because this is the deepest we're going to get probably. So if you follow to here, way to go. I'm really proud of you. So what we did, we created an extension on TableView data source. That extension is only valid if it's section containing and it's cell providing. And the section.item type is the section.item type of section containing is the same as as item type of cell providing. And that is why we can use this method, which is a method on section containing item at index path. We can use, oh, sorry, what did I do? So we can use the item of type item type that we get from the section containing protocol, and we pass this item into the method that is defined by the cell providing protocol. So because I told the compiler here, these types, they are going to be the same, I can use the type that I get from the one protocol and then pass it into a function from the other protocol to configure the cell. And now I see a mistake I made because we were talking about the returning of the cell, and we can, well, what I should have done was this, and then I should have made this variable if I wanted to actually use it, but we see that it works without returning and with using the type. And now it actually should show us our, oh no, because our data source still isn't section containing, it's still data containing. So let's get some sections in here. Let's make it section containing, and let's, we don't no longer need to specify data, but we need to, I'm pointing here, but we need to specify sections, we don't need to specify data, so let's say we're sections. And what are these sections? Well, our actors are conforming to section type, so it would be nice if we say here that our section is of type actor, and then we need to get the actors from the data source. And the James Bond movies are separated in sections according to the actor that played in it. But which actors? So I created this section type and I made it data containing. But what if we don't want to do more with a section? A section is not only containing data, but it also should specify what the header title of this section is going to be. But if we define this as a protocol, we always need to specify it, and probably, or sometimes, I don't even want to have a title of a section. Yes.
Right now, the header actors, I guess, are in the right order, so they match up in the. Okay.
Yeah. Let's comment this out. Yeah. So the order of these sections, and I've structured my data that this is complete. But if you wanted to sort it, you could easily make a protocol that says sortable, and then have an array that is sorted data, and then or have a function defined that sorts your data, and then you run your sorting function before you actually set the data, and then you have your sorted data. But now in my data, I've made sure that my actors are in the right order and that the movies are in the right order, but the movies are actually linked up to the actors. So we wanted to know who actually starred in these movies. Yeah, we have this header title, and well, this is a perfectly fine table view, right? I don't specifically need a header title, but I don't just want to be able to specify it at the time if it's convenient. So let's create, just to be nice to someone who tries to use this this protocol. Let's create a default implementation of header title. So what should all the default headers be? Well, it's optional, so we can just say, it's nothing. We can return nil here, and this should be public. So now section type is also, it also specifies a header title, but by default, you don't have to do anything. It's just nil, and it just has the default behavior. But now, if we have our actor that is conforming to section type, we can say, okay, this actor, let's also give it a header. This should be a var string, and we're going to return the name of the actor here. Now, what I still need to do is have in my extension on table view data source that is also section containing, I can implement the table, what was it again? Table view title for, let's make it a header in section. And we can just get the sections because this protocol is also section containing. We specify which section we have and we return the header title. And then we see that Daniel Craig starred in these 4 movies and the rest of the actors starred in the rest of the movies. So, that's pretty nice, isn't it? Well, the last thing we're going to do is make this movie data source. I like Star Wars much better. And say I want directors. And now if we conform extension director to section type, which I took care of earlier, so we don't need to have it again, then it should work, but it doesn't. Oh yeah, we need to specify that our section is of directors now. And we have all the directors of the Star Wars movies. Who actually knew that the Empire Strikes Back wasn't directed by George Lucas? I didn't. Sorry? So that's basically what I wanted to show you. So let's glance over what we've learned today. We learned that we can create protocols and we can conform types to protocols. We also can specify type aliases in a protocol and then later, when we are conforming to this protocol, specify which type this actually is. We can restrict the type that we are defining to be of a specific protocol. And we can create extensions on protocols that are restricted by which other protocols are implemented by these classes and which types are what are these called? Which type aliases are defined and restrict them even further. I also can say, well, this type should also conform to the protocol of the other type. You can do really funky stuff with this. So that's pretty much what I wanted to show you. Thank you very much. Are there any questions?
Yeah, so in the extension of table view DataSources, which is on the screen now,
Yeah.
You're comparing the type alias of self-section item type with self-item type, not self-item, self-providing.
Yes, so this one is coming from self-providing, and this one is coming from, let's just move this away. This one is coming from section containing, and this one is coming from self-providing. I can show you in the protocol themselves. So section containing has a type alias section, and that's what I'm using here. That's what I'm using here, and self-providing. Oh, it doesn't know where it is, but it's here. Self-providing has a type alias item type. And what's probably maybe a bit off-putting is that this is called item type. I could also call this cell item type. And then I define cell item type here. Right? These names don't need to match up because I'm specifying them here. But I was calling them the same in data containing and cell providing because then they automatically are seen as the same property. Is this clear? Or? Okay. Any other questions? Yes.
Do you think we could use generics instead of type aliases?
Yeah, sure. But generics don't work on protocols but on classes. I think. Correct me if I'm wrong. So if you want to use protocols and you want to... The thing I like about protocols, which I think I've shown here, is that you can create a lot of protocols that aren't really... Well, they're interoperating and they're coming together in this extension on table view data source. But you don't have to conform to all of them. And with subclassing, you can only subclass from one specific superclass. And here you can say, well, I screw this cell providing thing. I'm going to use my own way of configuring this cell and only using the convenient methods on section containing that is item at index path. I just want to use that functionality. And you can much easier compose different functionality with protocols. So, any other questions? Yes.
The extension on the array that you showed
Yes.
earlier.
Yes.
Can you still,
I removed it, but I can recreate it if you want.
can you still apply this with the?
Yes, you can. I tried. I wanted to make an example that actually had these things, but then, yeah, that's possible. You can basically say, I want my section here. We don't specify a specific section type, but we want a section to be an array of item type, and then we basically have we have items inside of an array. That are the sections, and then I have array, and that are the different sections that I have. And then, because array is data containing, you can just use this item type. Then the data that you provide can just be an array of an array. And because it conforms to these protocols, it's used automatically. but then you can't have headers in your sections, for example, because you don't have any data. And then you can say, okay, maybe I want a dictionary, and then I have like the dictionary, but then how do you specify the order of the dictionary? And well, it got a lot complexer, so I decided to go with this example. Any other questions? Yes. Sorry? Yeah, sure. The default implementation or the one that I can't stand all these things. Let's fix this again first. The default one, yeah, it's here. Yeah, sure. And I shouldn't have to. I don't use it at all. But it's just to make it, because you get the table view in these delegate methods of UI table view data source. I personally only use them to dequeue cells. I don't. Does anyone has a use case to use a table view other than dequeue cells? Because yeah.
Sometimes I have multiple table views in the same view.
Okay, and then you have a delegate, and then you need to specify which delegate you need to, or which table view you are providing with this data source, and you have the same data source providing to multiple table views. Yeah. Okay. So if you would want to do that, I just pass it through just to give you the opportunity, because when you're defining protocols, you're basically designing APIs, right? You're basically saying, okay, these are the things I'm going to work with, and then you're going to use them. So it's best to be broader in them, or give much more functionality and give as much data as it's logical to these protocols, even if you don't use them initially or in the default implementation. Well, that's my opinion, but I think that. Any other questions? Yes.
Will you release this code on GitHub?
Yes, this presentation, I'm going to update. No, there is a repo on GitHub. I'll show you. There is a repo of this presentation, which is called data. Come on. Yeah, which is called Data Sourceable Presentation, and it contains the playground and my slides and my notes. And there is a library I actually wrote which contains similar thing. Well, it contains this, but like a broader version of this, which is called Data Sourceable, and it is on GitHub. It isn't yet on CocoaPods Cartridge Swift package manager, but it will be. I didn't get around to get the right stuff for that. But this is basically what I've shown you today, and something more. So, any other questions? Okay, thank you very much, and let's have some drinks.